Hi, I'm an old guy and I do maths. Today we're going to look at perfect cube patterns, which allow you to expand cubics that look like this or like this in pretty short order. Now, this is really just a niche form of the general binomial theorem, but it turns up in textbooks, and so I thought it worth going into. So what each of these say is that a cube like this or a cube like this expands in a predictable way. It expands with the cube of this at one end of the expansion and the cube of this at the other, with a bit of a mixture in the middle. And we're going to look into that. We'll take one of these and do the expansion. So let's just get into it. Okay, so the first thing to note is that we've got some obvious coefficients in here, and the coefficients of an expansion like this are actually 1, 3, 3, and 1. Now we get these from the fourth row of Pascal's triangle. And again, those of you familiar with binomial theorem, this will be nothing new to you. But those of you who haven't seen it yet, or have never even heard of it, this may be something a little new. You can go and have a look at my video on Pascal's triangle, and you can see how the pattern is formed and how you get these rows of coefficient. It's not the only way, but it's by far the easiest way to do it. Now, the pattern says that we take the first thing we do is we place a cubed there, okay, and then as we move along, a cubed becomes a squared, and we insert b. That's actually b to the power of 1, and there is a b here, it's to the power of 0. And all of this is positive, so we've got plus signs all the way through here. The next step is just 3a. So you'll notice that we've gone 3, 2, 1, and over here we will be at 0 for the powers of a. B squared. And over here, a to the 0, b 3. Okay. Right, so let's take a really simple example and put this to work. Okay, so we'll try x plus 2. That's nice and simple, and we'll cube it. And we'll just follow this pattern. So 1, 3, 3, 1. Okay, so the first step is 1x cubed plus 3x cubed b to the, b, I said b, 2 to the power of 1. So 3x cubed 2 to the power of 1. What that's going to do is give us 6x cubed if we tidy that up. Next step, which hopefully I don't foul up, 3x to the power of 1, b, this thing, to the power of 2. 2 to the power of 2 is 4. So we can tidy this up. We get 3 times 2 to the power of 2, which is 3 times 4, which is 12, 12x. And our last step is to cube the 2. 1 times 2 to the power of 3. There is an x in here, but it's x to the power of 0, so we'll just leave that alone. So just to recap, and sorry about the mess here, this expands, according to this rule, to x cubed plus 6x squared plus 12x plus 8, which is what this is. So let's get that all written and tidied up, and there we are. And so when you confront this, something like this, and you're asked to factorize it, one of the things that you should check first and foremost is whether the thing here and the thing here are cubes of some sort. And that might give you a way into factorizing something like this really quickly, because if you can recognize this and you can see the pattern, you can look at it and amaze friends and family by going, oh well, that's just x plus 2 all cubed. Thanks very much for watching. I hope this was helpful. See you next time.